Hi guys, I hope you're good. I hope you're well and excited for our lesson today. We are still working with equations, and what we are looking at specifically today is solving simultaneous equations, linear equations in two unknowns. So we are working with simultaneous linear equations, but with two unknown variables, and we are looking strictly also at the method called elimination. So we will be using this method only on this lesson. If you want different methods, we have them on the next lesson. So we still have a lesson on substitution. We still have one more method called equating. So we have quite a number of methods that we use whenever we are trying to do simultaneous equations. So please grab that pen and paper and get ready for this lesson, guys. So up to now, we have solved equations with only one unknown variable. So what I've been giving you, or what you've been working with in the previous lesson, has been equations that look like this: x equals to 1, or x squared equals to x squared minus 4 equals 0. So you've been working with only one variable, which is x, y, or z in that particular problem. But when solving for two unknown variables, that's what we're doing now. Two equations are required, so you need at least a minimum of two equations, and these equations are known as simultaneous equations, because the word simultaneous simply means same time. Okay, so that's what it means. So it means you're working with things at the same time, and the solutions are the values of the unknown variables which satisfy both equations simultaneously. So that is what the solutions are. So these solutions will have to satisfy both equations at the same time. And in general, if there are n known variables, so if you're working with two, n can be any number. It can be 2, 3, 4. So if you have n unknown variables, then n number of equations are also needed. So you need n independent equations will be required to obtain the values of each n variables. So that's how simultaneous equations work, guys. Now you have the first example. It says solve the following system of equations. So this equation has both x and y. And remember that the method that we're using this time is called elimination. So this is how you use the method. So if you have x and y there, x and y on the other side, you simply draw a line and add the two equations together. So it means you're adding like terms together. So you add 3x and 6x. So if you add 3x and 6x, you find yourself with 9x. And you move to the second part. You have a positive y and the negative y, so they both give you 0. So if you have 1 minus 1, that gives you 0, so you don't have to write it anymore. Now you're going to equate that to what is 2 plus 25. That is going to be 27. And now you have formed another equation, so it means you've added the two equations. So these two equations give you that. And you divide this by 9 both sides because you're solving for x. So this is going to be x equals to 3, because 27 divided by 9 is 3. And you formed another equation which you can call equation 2 this time. And now you need to substitute equation 3. You can actually choose whether you want to substitute in equation 1 or equation 2. It should give you the same answer, because the reason why you got x is equal to 3 is because you've added the two equations together. So you substitute equation 3. Let's choose equation 1 this time, for example. So if I choose equation 1 like that, just make some space there. So this means, let me rewrite equation 1. So equation 1 is 3x plus y equals to 2. So let's substitute x equals to 3 in that space there. So this is going to be 3 open brackets. This becomes 3 plus y equals to 2. So what is 3 times 3? That is a 9 plus y equals to 2. And therefore y will be given by 2 minus 9, because the 9 needs to go to the other side when we are grouping like terms. So now you are left with y equals to negative 7. But let's just say we're trying to actually prove if indeed if I choose equation 2, will I manage to get the same answer. So now let's try to substitute equation 3 into equation 2 this time around. So just a disclaimer, guys, you don't have to bring up the two methods. You just choose one, okay? Because the other one you'll be wasting your time on an exam. So just choose one equation. Just be confident after eliminating the values, you found the value of x. So choose whether equation 1 or equation 2, they will both give you the same answer. So you don't have to do both methods. No. You just choose one equation. So now we've also chosen equation 2 because we're just trying to check if it will indeed give us negative 7. So if I write equation 2, it's 6x minus y equals to 25. And if I substitute if I substitute 3 into the space of x, so this is going to be 3 minus y equals to 25. And what is 3 times 6? That gives you 18 minus y equals to 25. And if you now group your like terms, you're going to take the 18 to the other side. So this is going to be negative y equals to 25 minus 18, because the 18 had to jump the equal sign now. And this is minus y equal, what is 25 minus 18? That gives you 7. And if you find yourself with such a case, you're looking for y, not minus y. So you need to divide it by negative 1, both sides, so that now becomes positive. So you have y equals to negative 7, and that is exactly the same value that we found earlier on. So that's why I was saying you only choose one part so that you don't waste time trying to prove that indeed you're correct, okay? But let's say during practice, you're trying to find which, you're trying to see if actually the value of x or y is correct. You can use both of the equations just to ensure that you master your skill. But once you've mastered your skill, guys, you only choose one part, okay? So here you are talking about around 5, 6, 7 marks or 8 at maximum. So that is how we actually work around simultaneous equations. Now, example number 2. It says solve simultaneously using elimination. So we have 4x minus 5y equals to negative 18 and negative 4x minus y equals to 6. So let's try to solve x and y in that problem. So I'm going to rewrite equation 2 just next to equation 1. So this is going to be negative 4x minus y equals to 6. So that is equation 2. And draw up a line and add the two equations together. So if you add 4x and negative 4x, you are going to get a 0, so you don't have to write it down. So now you are left with negative 5y and negative y. So those two values give you negative 6y. And this is equal to, you have negative 18 and 6. So when you add the two values together also, you get 12. So it's a negative 12. And now you can divide by negative 6, divide by negative 6 both sides. Therefore, y is given by positive 2, because you have a negative and a negative there, they give you a positive value. So please, now what you do is you need to substitute. So now it means you created equation 3. So you have to substitute equation 3 into any of the equations of your choice. So let me substitute it into equation 1. To equation 1. So equation 1 is written as 4x minus 5y equals to negative 18. And in the space of y, I need to substitute in 2. So this is going to be 4x minus 5, open brackets, that is a 2, equals to negative 18. And this is 4x minus what is 5 times 2, so it's a minus 10, equals to negative 18. So we're going to take the 4 to the 10 to the other side, so this is 4x equals to negative 18 plus 10. So I took the 10 to the other side, so this is going to be 4x equals to what is negative 18 plus 10, that is going to give you negative 8. And now you divide both sides by 4, that cancels out, so therefore x is given by what is negative 4 divided by negative 8 divided by 4, that is going to give you a negative 2. So that is the value of x, and that is the value of y. So you can actually attempt this value using the second equation, and trust me guys, it is going to work out. It is going to give you a negative 2. So guys, this is how you do simultaneous equations using the method called elimination. And trust me, I have more lessons on other methods, so you can watch our next video and you will see the method called substitution. And trust me guys, you will choose whichever method that you want to work with whenever you're working with simultaneous equations. So thank you for joining me, and I will see you on the next one.